constant here. So
Right.
we'll see if this made clear. So number 5 here, it says to find the value of the 6 trigonometric functions. We'll get to that in a moment. The first thing is you need to find the hypotenuse of this triangle, and that comes from a squared plus b squared equals c squared. So 9 squared plus 12 squared equals c squared. So 81 plus 144 equals c squared, like that. So this is 225 equals c squared. And then you look at this number, and I think if you're allowed to use a calculator, which I mean, that might change, but this becomes 15.
Yeah.
Okay. Now you might have said to yourself, like, well, maybe I should have known that. And the answer is, well, there are what are called Pythagorean triples, and these are the nice ones. And I don't know how much of this you're going to get into, so we don't have to spend too much time on that, but sometimes they work out nice, but most of the time they actually do not. So you should not expect them to work out nicely. We'll see that in 7 that it doesn't. But okay, so from here, I'm just gonna redraw the triangle, frame this a little bit better. So we've got theta up here, 9, 12, and 15. So let's start with sine. Sine of theta is the opposite over the adjacent. So from theta, opposite is 12. Okay, is that okay? Like it's not the hypotenuse. So 15 is the hypotenuse in this problem. 12 is opposite. And then the 9 is the adjacent.
Yes.
Okay, and so let's review like what these are. Hypotenuse is always the longest side, or the one across from the 90, always. The adjacent is the one next to. Now you might think, well, isn't the hypotenuse next to? It is, but it's already got a name. So we go adjacent's the one that's next to. Opposite is the one that's, I don't know, more across, I'll say. But they use the word opposite in this. So it's 12. I'm sorry. I apologize. I really messed this up. Sine is opposite over hypotenuse. So this one is 12 over 15.
Okay.
Okay, so you probably saw this in class, and you do have to know this relationship
Right.
for sine, cosine, and tangent. All right, so now you do reduce as well. So this is where there's like a lot of steps. You can divide the top and bottom by 3, 4 over 5, like that.
Yes.
Okay, so now cosine of theta is the next one. It is adjacent over hypotenuse. What 2 numbers would that be?
Adjacent would be 9
Okay.
over, and then hypotenuse would be 15. So 9 over 15.
Good. So we can reduce these again. You can divide top and bottom by 3, 3/5. Okay, now there's actually 2 ways to do tangent. Okay, so most students learning this for the first time, they use the O and the A, the opposite over the adjacent. So that's the 12 over the 9, or 4 over 3.
How do you know like which one is adjacent? I know how to tell which one's hypotenuse, but
So the adjacent's the one that's next to the angle, like, but it can't be the hypotenuse. So like see how it's kind of like next to the angle,
okay.
and then the opposite, the one that's like across, almost.
Right.
And
Okay.
that's how you know. Okay, now I'm not sure how they're showing this to you in the book, but or in the class, but cosecant of theta, this is the 4th one. It's better to remember it as the flip of sine. I don't know if you've seen this yet, but this is the better way. rather than trying to remember it as hypotenuse over opposite, it's the flip of this. The flip of this one here. So what 1 over means the flip. So you could write 1 over 4/5, but this becomes 5 over 4. Do you know if that was described in class or not?
Yes.
Oh, good. Oh, good. The secant of theta is 1 over the cosine of theta. And again, it's the flip. Like going forward, I'm not going to write this. I'm just going to flip it and write 5 over 3.
Right.
Okay. And then cotangent of theta is similarly 1 over tangent, 1 over 4/3, which is the flip, 3/4.
Yeah.
Is that okay?
Yes.
So your instructor just wants, like, you don't have to show any of this intermediate stuff. They just want 4/5, 3/5, 4/3, and so on. You have to know which ones pair up. You have to recognize that sine pairs up with cosecant because it's reciprocal. Same thing with cosine. Cosine is the reciprocal of secant. Tangent you can actually get 2 ways, but tangent and cotangent go together. Tangent actually comes from sine and cosine, believe it or not. So if you can get sine and cosine, you can get everything else, is the point here. All right, so we went
Yeah.
really slow for that first one, but it was necessary. We'll move to 7 now. Same set of steps, but it's going to be a little bit more difficult because this one will have a root to reduce. So let's take a look here. So again, you got to find all 3 sides. So this time it's missing. We'll just call this a squared plus b squared equals c squared. So you have a squared plus 5 squared equals 7 squared. So a and b are the legs. They're the ones that come out from the 90. C is the hypotenuse.
Oh, right. Okay, I remember that from geometry.
Yeah. Okay, so to solve from here, you have to square the 5, that's 25, square the 7, that's 49, subtract the 25,
Mm-hmm.
so that becomes 24, and this is where you have to reduce the root. You have to be comfortable reducing the square root of 24. Okay, so that's 2 and 12, 2 and 6, 2 and 3. Do you remember what to do from here now that this has been built?
So isn't it you like circle the 2s
Yes, the pairs. There's one pair. They
and
come out.
then and then the 2 and the 3 you add or you multiply them?
Multiply them. Yeah. So this becomes 2 square root 2 times 3 or 2 square root 6.
Okay.
Your instructor expects you to do this. So like before, like what we just did is like one is like a problem, but now it's like you just have to do it. You have to be like, okay, I'm super comfortable with this. That's where this gets hard, is there's so many steps. Let me know when you get all this down.
Okay, I'm good.
Okay. So here we go. We got, I'm gonna just redraw it here. 5, 7, and then 2 square root 6. Okay. So there's 3 words here: adjacent, opposite, and hypotenuse. Which one, actually, let me do it over here. Which one is the adjacent or opposite or hypotenuse? I'll just say like 7 is, tell me what 7 is, tell me what, 2 square root of 6 is.
So 7 is hypotenuse.
Okay.
And then 5 is adjacent.
Okay, so 5 is actually opposite.
Oh, I was looking at the right angle, not the actual. Yeah, okay.
So
Sense.
it's relative. Yeah, I can see why that would. Yeah, so relative to the theta, 5 is opposite. This is the adjacent. Okay, so start with sine. Sine theta is opposite over hypotenuse. Can you give me those two, please?
So it would be 5/7.
Yes. Cosine theta is the adjacent over the hypotenuse.
So 2 and then square root of 6 over 5.
Hypotenuse,
I mean 7.
7. Tangent of theta is opposite over adjacent.
So 5/2 square root of 6.
So this is where we have our first, yet again, like another detour. So you're expected to know that you need to rationalize, which means no square roots on the bottom. So you have to multiply the top and bottom by the square root of 6. You may, so in the back of your book, this will be rationalized, but you may want to ask your instructor. You probably say, yes, you have to rationalize, but it's yet again another diversion, another little place for work. Does that at all look familiar from class or?
Yes.
Okay. So in the numerator, it's 5 square root of 6. In the denominator, square root of 6 times the square root of 6 is the square root of 36, which is 6. 2 times 6 is 12. Okay, so we're going to go back to, in the order, like you don't want to do these arbitrarily. You want to do them in the same order every time. And I would recommend doing the order I'm in: sine, then cosine, then tangent. And another reason is because tangent is sine divided by cosine, which you'll see at some point. But then the cosecant matches up with the sine. It's the flip.
Right.
Okay. Secant theta is the flip. But what's the problem with what we have written here?
It has the radical in it.
Yeah, you have to rationalize now. And depending on your comfort, this could be a whole new problem in some ways.
Yeah.
That's a lot to ask. So then cotangent theta is the flip of tangent. Now, this is important to notice here is for cotangent, we can actually use either one of these. Now, I want you to look ahead here a little bit. If we flip the one on the right, where will the square root be?
Sorry, say that again.
So notice that cotangent is the flip of tangent, but we can flip any one of these that we want. Like doesn't have to be this one.
Okay.
And here's why. If I write 12 over 5 square root of 6, what do we have to do?
We have to rationalize it.
Right. And if I write 2 square root of 6 over 5, do we have to rationalize that?
No.
So you want to be very selective about which one you pick
Yeah.
to save yourself this awful mess.
Yeah.
All right, so we're up to 9. Any questions so far?
No, I'm just writing down the last one.
Okay.
Okay. We're all good.
All right, so 9 again, like it's the same set of steps. A, B, and C. A and B are always the legs. They're the ones that come out from the 90. C is always the hypotenuse. You're using the Pythagorean theorem. A squared plus B squared equals C squared. So A squared plus 10 squared equals 18 squared. Okay, so A squared plus 100 equals maybe 376. I'm gonna check that. 324. thinking of something else. And then you subtract the 100, so a squared equals 224. You have to take the square root of both sides. I'm surprised they gave you this one, but you know, this in itself is kind of its own headache of a problem.
Right.
Okay. So you circle pairs. This one has more than one pair. And then the 2 and the 7 are left over. Is that
Okay.
okay? Is that okay up to that point?
Yes.
All right. So again, I gotta sort of redraw everything here. Ten, 18, 4 square root 14. Okay. And then the angle is really important. It has to be in the same spot. Okay. So again, kind of those three words, you know, adjacent, hypotenuse, and opposite. What is give me, I'll take any of those three. Which is the adjacent, which is the opposite, which is the hypotenuse?
The adjacent is 10. And then the hypotenuse is gonna be 18. So then opposite's gonna be the 4 and then the radical 14.
Okay. So now we can write our you know, start out with sine. Sine is opposite over hypotenuse. Okay, so that's 4 square root 14 over 18. So this is not done. This is we now have to actually do a little bit of simplification. Like, see how you can divide the top and bottom by 2. That's also a little wrinkle here. What you cannot do is you can't manipulate anything inside the square root. So just the numbers on the outside. So is that okay?
Yes.
Cosine of theta is the adjacent over the hypotenuse, so 10 over 18, which is, you can divide the top and bottom by 2. Tangent of theta is opposite over adjacent, 4 squared 14 over 10. All right, so this is probably a good time for me to give you this reference sheet that I really like. It will look a little overwhelming, but a lot of what we're doing is on the first and second pages. So let me just drop that in the chat. So you'll use this for the rest of the year if you're doing trig. So it might be worthwhile to print that out and have it handy while you're doing this. So from here, you can reduce the 4 and the 10. Two square root 14 over 5. And then this is where you do the reciprocal ones. So cosecant theta, you flip it. So it's 9 over 2 square root 14. But this is a problem. Like you can't leave it like this. You have to rationalize. most of these do not work out nice. So this is 2 times 14, which is 28. Secant theta here is the reciprocal of cosine, so 9/5. Got a short one there. And then cotangent of theta. So this one, when you flip it, 5/2 square root 14. Square root of 14, square root of 14. 5 square root 14 over 28.
Okay.
All right, now I would normally have you say, okay, you really, Isabel, is you do one on your own, but like you're going to do more of these in 13, 15, 17. So we'll just keep going here. But like, is there any questions? Like cause obviously seeing me do it, it probably looks easy but there's all these little paths, forks in the road. Anything that's unclear?
No, I think I'm just like, I need to get used to figuring out what or like how to rationalize.
Okay. We could spend a few minutes talking about rationalizing again, if you would like. If that would help.
Yeah.
Okay. All right, let's do that here. So here's kind of your basic rationalizing problem, okay? And whatever's on the bottom, you multiply the top and bottom by the square root of that. Okay, so like you say, okay, it's square root of 2. I'm gonna multiply the top and bottom by the square root of 2. Now I was skipping a few steps here. It's really the square root of 4 on the bottom, and the square root of 4 is 2, so it's 5 square root 2, like that. So here's another example here. Let's say it's let's go 9 over the square root of 3. So what would you multiply the top and bottom by here?
So you multiply it by the square root of 3.
Yes. Okay. It's always the same. Like if you do one thing to the top, you have to do the same to the bottom. It's got to be consistent. So this is in the top 9 square root of 3. You cannot multiply inside the square root. On the bottom though, because they're both square roots, you can get the square root of 9.
Okay.
Okay, so this becomes 9 square root of 3 over 3. Do you see that?
Yeah, yeah.
All right. Now this is where you can divide the numbers, but not with the square root.
Okay.
So this is 9 divided by 3 is 3 square root of 3.
Right.
All right. So in the previous problem, 5 didn't go into 2, so we just left it. But this one you could see, okay, it divided. Okay, in fact, it divided perfectly.
Yeah.
Okay, so here's one for you to try. What is a 10 over the square root of 5?
So you multiply the top and bottom by the square root of 5.
Yes, yes. Okay, so go and work this out.
So would it be 2 radical 5.
Yes. Good. Now it doesn't have to go in perfectly. Like it could be 12 over, I'm sorry, let me do this differently. It could be like 6 over the square root of 4. No, sorry. Sorry, I'm really losing my mind here. Never mind. Sorry. So any questions on these? Because I'm going to just change up the problem a little bit. So you just multiply by the top and bottom by the root, like you've been doing. Is that okay?
Yes.
All right. All right. So the next type of problem you might see is something like 10 over 3 square root 6. Okay. You still multiply the top and bottom by the square root of 6.
Right.
Okay. And you just go as far as you can go. So it's 10 square root 6, 3. Square root of 6 times the square root of 6 is 6. Is that okay?
Yes.
And then you keep going, 10 square root of 6 over 18. But then can you reduce anything, specifically the numbers outside the root?
The 10 and 18, you can divide by 2.
Right. So this becomes 5 square root 6 over 9.
Okay.
All right. So now let's have you try one. Let's go 12 over 5 square root 3.
So it'd be 4 radical 3 over 5.
Yes, that is correct. Or 4
Okay.
fifths square root of 3. Yeah. Or 4, like you said, 4 radical 3 over 5. So now the only way this maybe gets like weirder or more difficult, like sometimes you can just have a square root on, you can have square roots in the top. So it'd be like 4 square root 2 over square root 3 on the bottom. You still multiply the top and bottom by the square root. Okay, so just like in the previous problem here, now on the bottom it becomes 3. In the top it's 4 square root 6.
Okay.
All right, so I'm looking here for a quick worksheet to see if I've covered all the cases, because I didn't. We did that one. We did that one. So yeah, again, here just a few. I mean, here's like a practice problem for you to try in no particular order. 8 over 3 square root 2. What would you do with that one?
So you would multiply the radical 2 to the top and bottom.
Yes. Go ahead and give me your final answer on this.
So then it would be 4 radical 2 over 3.
Yes. Okay, good. So there is another type of problem here, and this is probably going to be the extreme edge of where we're going. But let's say it's like something like 6 over the square root of 12. You might think to yourself, well, I'll just multiply the top and bottom by the square root of 12, because that's what Matthew's been saying the whole time, and that would work. The problem is the square root of 12 can be reduced. Okay, so in all the problems I've given you, square root of 2, square root of 3, and so on, you couldn't reduce any of these roots, okay? In the original problem, right?
Yeah.
But and this is why this is the last one, because I don't want to spend our whole lesson on this, but you really should reduce square root of 12 first. That's 2 and 6, 2 and 3, 2 square root 3, like that.
Okay.
Okay. Now from here, this is where you have options. You can actually divide first. This can become 3 over square root of 3. And you still have to rationalize, but the point is that there's, variations on the steps here for the direction you want to go. So this becomes 3 square root 3 over the square root of 9, 3 square root 3 over 3. The 3's cancel, and it's just the square root of 3.
Okay.
All right, now I know that was a lot. Some of it will come into play here. Let's look at number 13. So 13 says to find the other 6 trigonometric functions. So to do that, we want to draw the triangle. So here is the triangle here. And it's good to draw the same kind of triangle each time, okay? Theta's there. Now this 7 over 11 is opposite over hypotenuse. So A, B, and C, which is the opposite and which is the hypotenuse?
The opposite is B.
Okay, what's the hypotenuse?
C.
So that's 11. See how I label those from the given information?
Yes.
All right. You first want to find the triangle. You cannot do this without finding the triangle. Okay, so this is a squared plus b squared equals c squared. A squared plus 7 squared equals 11 squared. Okay, so you're gonna subtract here and get 72, I believe. Yeah, that looks right. Can you go ahead and reduce that for us, please? Tell me what you come up with. And if you have questions, please ask.
Wouldn't it just be 8 and 9?
It is, but you've got to go through the motions here of 2 and 36, 2 and 18, because you have to know what to pull out.
Okay. So then you'd have a pair of 2s and a pair of 3s.
Yes, so they each come out.
Right.
So this becomes 6 square root. What's left over? What's on the inside? What number is left in this list?
Oh, 2.
2, yeah. So while what you said was correct, I mean, it is 8 times 9. You have to know how to reduce that. You have to know that it becomes 6 square root 2, and you may not have been able to figure that out from that. So that's why this factor tree really helps here. Again, it's just one part of this problem. There's so much to do, here. Okay, so let's do cosine now. Cosine of theta is the adjacent over the hypotenuse. What is the adjacent?
The adjacent is 6 radical 2.
And the hypotenuse is 11. Does this need to be rationalized?
Yeah. Oh shoot. No.
It does not. Only when the square roots are on the bottom.
Yes.
Okay, perfect. So this is done. Now we've got to do tangent. Tangent of theta is opposite over adjacent. The opposite is 7. The adjacent is 6 square root of 2. Does this need to be rationalized?
Yes.
Could you rationalize this for us?
Yes. So you multiply the radical 2 to the top
And the bottom, good.
and the bottom.
Mhm.
So it'd be 7 radical 2 over 12.
Yes. Very good. So now we go back, cosecant theta, that matches up with sine. It's the flip of sine. Reciprocal flip, 11 over 7. Secant of theta is the flip of cosine. So that would be 11 over 6 square root 2. And again, you have to rationalize this. If it's not, could you rationalize this for us and let me know what you come up with?
Yes. So it'd be 11 radical 2 over 12.
Yeah, good. And then cotangent of theta, we talked about this earlier. You have your choice. You actually can go back to either of these to flip. And you really want to flip the one where the radical's on the bottom, so it goes to the top. So it would be best to do this 6 root 2 over 7.
Yeah.
Okay, now if you're like, well, if you don't do that, let me just show you what, if you don't do that, if you do the 12 over 7 root 2, you have to rationalize. So it becomes 12 root 2 over 14. And then you have to remember to simplify, and it comes back to that one there. So you're at a point where it's like you really want to save time if you can. Now, we're obviously not going to get through all of this tonight. I hope this isn't all due tomorrow. Maybe.
Oh, yes. I can still finish it though, like if we end early.
Okay. Well, yeah, we're just not gonna, I was going to say I can go through like 21 if you want, or it's up to you. Or you can keep going on these 13, 15, 17. What would be best?
Let me see again. Maybe the 21 through 26.
Okay. All right. So this is kind of its own lesson in itself. These are 30, 60, 90 triangles. And what I mean by 30, 60, 90 triangles is those are the angles. So this other one up here is 30 degrees. And these have a really special relationship. Basically, you can do everything in the triangle from one side. Okay. All right. So the reference triangle is what I'm drawing on the right here. The short leg is across from the 30 degrees. And it's usually shown as X, just like in the problem here. The hypotenuse is 2x. And then the long leg is the short leg times the square root of 3. Okay, so there's this expectation that you know the reference triangle. Now there's another way to do this with just using Pythagorean theorem, but this is the preferred way, is to know the reference triangle here.
Mm-hmm.
And the reason you want to know this is because you want to set the known side, that's the one that's given, to the reference side. So in your problem, you're setting this 9 equal to the 2x. Okay, so where this gets confusing is when you solve for x here and you get x is 4.5. Well, what is x? It sometimes is the x in the problem, but it's always the reference x. It's always the short leg. So this is the short leg. And you have to decide if that's what it actually is in this problem. It is, and it is in fact the short leg. So the mistake here, just to be clear, the mistake here is to think, oh, I've got it. Why is he explaining so much? Like these get way more complicated, but it always comes back to setting the known side to the reference side. It's just, I don't know how deep into this topic you're going. So
Yeah, me
I'm not,
neither.
I don't want to rush through this, but I also am like, well, could be something we could talk about next week. So again, here, 30 degrees. So I used to, and I recommend this drawing the reference triangle. The short leg is x, the hypotenuse is 2x, the long leg is x root 3. And just like in the previous problem, you're going to set the known side equal to the reference side. You're going to set 6 equal to 2x. So x equals 3. And that is your answer. It's totally your answer. It's just, can we just jump to and say that it's always, take that and cut it in half? I mean, it depends on the problem, frankly, but seems to be working out here. So 23 is really similar. If I draw the reference triangle again off to the right, notice I always draw the reference triangle in the same orientation as the given one. That way it's clear. So just like in the previous problems, you're going to set the hypotenuse equal to 2x. Which means x equals 6. (24). Any questions on that before we go to 24?
No, we're good.
Okay. Okay, so Jen, same thing. And by the way, if you go to my YouTube channel, I've got a bunch of lessons from students over the years on special triangles, if you're curious or get stuck on a homework. But you always set the known side equal to the reference side. So in this case, again, they're giving you the hypotenuse. You set it equal to 2x. You solve for x by dividing by 2. And that, again, just happens to be this. So no more work to do.
Okay.
Now 25 and 26 are a different type of special triangle. There's two special triangles. This one is a 45, 45, 90. And again, that refers to the angles. This one's easier. Usually this one comes first when they're teaching it, but in your case, it's come second. So the legs are the same. The legs are always the same. That's what's key here. The legs are the same. It's an acute right triangle. The hypotenuse, which I know it's not asked for in this problem, the hypotenuse is the leg times the square root of 2. Okay, it's not asking for it, but that's what it is. So in your problem, the other leg is 8, and it's because these sides are congruent. So from what I'm seeing here, it looks like you'll probably discuss this in more detail in a future lesson.
Yeah, I'm guessing that's probably going to be our lesson tomorrow.
Yeah. So probably you can tell me here on 26, what is the value of x, since it's the same type of triangle that we just looked at?
Oh, sorry. Can you go back to the other one? I wasn't finished.
Sure,
I
sure.
forgot to
I'm
tell
sorry.
you.
I'm
No,
sorry.
you're good. Okay. Why did you do 45 minus 45 minus 90?
That's the name of the triangle. It's called a 45, 45, 90 triangle.
Okay.
And those are the angles, 45, 45, and then the 90.
Yeah. Okay.
And,
Okay.
and you actually saw me do that earlier. It's 30, 30, 60, 90.
Yes. Yeah. I was like, what are the minus signs? But then I got the yes.
All right. So 41's cut off. 43 is weird. So I'll just kind of start at 45 here. We don't have enough time to really do it, but plus it's got the picture. The picture is really key for you at this point to be able to draw these. Sorry about that. Oh, we didn't do 26. Never mind. We need to do 26. So the value of X is the other leg. The legs are the same. Legs are the same. They're equal. So X would be 7.
Yes.
Right. Okay. So this, reality is this is a really long lesson, and